over 2y, sketch a slope field of the differential equation on the coordinate plane. For this particular equation, we can back up to the original equation. It is possible. So a slope field isn't absolutely necessary for this, but is part of what's being asked for us to do. And I know that's not good or English, but too bad. I'm a math teacher. So let's look at where x is 0. The zeros are the easy ones to get right away, in my opinion. So x is 0 along the y-axis, and when x is 0, then the slope is going to be 0, except that's 0, 0. That's going to be undefined. And so there we go. So we got the y-axis. What about when y is 0? All of those are undefined because that puts 0 in the denominator. So we can knock out a column in a row pretty quickly by looking at zeros, especially when it's division. All right, now how about 2, 2? Now this is tedious. It's going to take a while, so hang in there, play along, and it'll be a lot more fun. All right, so negative 2 over 4, right? When we plug in 2, 2, negative 2 over 4, negative 1/2. So negative 1/2. I need a negative slope and fairly flat. That's probably too flat. That's all right. 2, 1. That's negative 2 over 2, so that's negative 1. Like that. All right, so 2, negative 1. 2, negative 1. Plugging in over there, that's negative 2 over negative 2, that's 1. Slope of 1. And then 2, negative 2. That's negative 2 over negative 4, so that's a positive 1/2. Maybe something like that. A little flatter than the 1. All right, here we go. 1, 2. That's negative 1 over 4. Negative 1/4. So pretty flat. Flatter than a half. Whoops, that's positive. I need to make it negative. Try that again. Exactly. 1, 1. That's negative 1 over 2. Negative 1/2. And then 1, negative 1. That's going to be negative 1 over negative 2. That is a half. Positive half. It's like that. 1, negative 2. Negative 1 over negative 4. So 1/4. It's flattening out. Negative 1, 2. That's 1/4. 1/4. Negative 1, 1. 1/2. 1, negative 1. Negative 1 over negative 2. A half. Oh, wait, no. That doesn't make sense. Negative 1, negative 1. There we go. So it makes that positive. Negative 1/2. It helps that I know what this is supposed to look like. Negative 1, negative 2. 1 over negative 4. Negative 1/4. So flattening out like that. All right, last column. Here we go. Negative 2, 2. So 2, 4. 1/2. Negative 2, 1. 2, 2. That's 1. Slope of 1. And then negative 2, negative 1. That's 2 over negative 2. That's negative 1. And then finally, I'm running out of room. Negative 2, negative 2. That's 2 over negative 4. It's negative 1/2. Like that. Take a look at that slope field kind of in its entirety, right? So what kind of graph does that look like? What do you think? You see it? Sketch a possible solution curve of the differential equation that passes through 0, 1 on the coordinate plane above. So 0, 1. So if I follow these, probably circles, is what I'm seeing. I'm seeing a circle with all those little tangent lines. Now imagine taking a computer and not having 30 or whatever is up there. Imagine having 3,000 little tangent lines. You could get a pretty good idea of what the original graph looks like. Down at the bottom here, I'm going to go full width now. Page width. Go down to letter C. We sketched the curve. This is dy over dx equals negative x over 2y. It says find a particular solution for the differential equation that passes through 0, 1. Now, when we get to the DCA and the test, students have a tough time, so just leave it blank. But I think it's because when we think of a solution, we're thinking of a value. We're thinking of a number. But the solution to differential equations is an equation. And we're backing up to the original equation. We got to get 2y with dy. We got to get x with dx. So we're going to multiply by dx, multiply by 2y. So we're going to get the y's with the dy's, the x's with the dx's. Integrate both sides. So y squared is equal to negative 1/2 x squared plus c. Now normally with a conic, I got to find the c first. I'm getting ahead of myself. 1 squared equals negative 1/2 times 0 squared plus c. And here's my warning to you. Heed my warning. I've done a lot of these. As soon as you integrate, as soon as you go from this step to this step, plug the value into this step. And I know you haven't done a whole lot of these, and you may not understand what I'm talking about. Like, what do you mean by that? Don't manipulate the equation now. Don't start manipulating. Don't add the 1/2 x over, or certainly don't square root and then plug it in. Do not manipulate this equation in any way. Just integrate, plug the value in right away, and your life will be so much easier. Not that you can't do it that way, it's just I know the easy way. I like the easy way, by the way. I don't like the hard way. I'm telling you the easiest way to do this. So c is 1. Now we got to plug c back into that equation. Y squared equals negative 1/2 x squared plus 1. Now, since this is a conic section, it is a circle. What would be an ellipse? It's an ellipse. But anyway, we would add that 1/2 over. But I think calculus, they just want us to write y equals. So get y by itself, and you'll probably get all the points. Questions on that? How do you solve a differential equation? It's not a value that we're looking for. It's an equation. It's another equation right there. Use Euler's method to approximate the particular solution of the differential equation. Y prime equals x minus y, passing through 0, 1, and use a step of change in x equals 0.2. Now this is all decimal, so we're going to grab a calculator. Yes, I am. This y prime can be written as dy over dx is equal to x minus y. And then for Euler's method, we're going to split the differentials. dy equals x minus y times dx. dy and dx are changes in that variable. dy is small changes in y. dx is very small changes in x. Now we're starting out with, they tell us, the point 0,1. 0,1. They're telling us that the change in x is 0.2, and we want y when x is 0.2. So we know what the x's are going to do. It's going to go 0.2, 0.4, 0.6, and finally we'll be able to approximate 0.8. Now this answer is not the exact value of y at 0.8. It's an approximation of what we would get if we plug 0.8 into the original function, not the derivative, but the original. So we know what dx is doing. Now, how is y changing from point to point? Well, that's defined by x minus y. We have an x, 0. We have a y, minus 1. And we have dx. It's 0.2. So going from the first point to the second point, x changes by 0.2. Now we know that y, I don't need a calculator for this, but if I go 0 minus 1 times 0.2, we find out that y decreases by 0.2. Well, 1 minus 0.2 is 0.8. So y just became 0.8. Now we would go 1 minus 0.2, and we would get 0.8. Now the next step is now 0.2 minus 0.8 times 0.2. So 0.2 minus 0.8, got that, times 0.2. So now the y, this is 0.2, the y decreases by 0.12. So we're going to take our 0.8, the y that we just got, 0.8, and we're going to minus 0.12. So now 0.68. Let me tell you what we've done. Now we've approximated. What would we get approximately if we put 0.4 into the original equation? We would get approximately 0.68. But we got to get to 0.8. So now we have 0.4 minus 0.68, and then times 0.2. Now the y is decreasing by 0.056. So I'm going to take 0.68 minus 0.056. It's very repetitive now. So this ends up being 0.624. All right, where did I get that? I got 0.4 minus 0.68 times 0.2, and that equaled negative 0.056. Here we go. This is the last step, by the way. 0.6 minus 0.624. We're going to multiply that by 0.2. We're going to get a value. 0.6 minus 0.624 to get that value, times by 0.2. So now y decreases by 0.0048. So we go back to the y, 0.624 minus 0.0048, and that's our answer, 0.6192. That's all approximations, though. Those are not exact values. Euler's method is only an approximation. Questions on this process? It all stems from what this means. That means that, so you split it into that. dy is little changes in y, dx is little changes in x's, go. It says approximate y of 0.08, so my answer is really 0.6192. Good question. I picked this one for a very specific reason. There's a very common mistake on this one. All right, so it says solve the differential equation if f of 0 equals 1. They give you a point, f of 0 equals 1, so that you can find the c. We got to split y's with y's, which is 1 over 3 minus y dy is equal to cosine of x dx. So there's x's with x's, y's with y's. Our next step to solve differential equations is to integrate. We're backing up to the original function. What is the antiderivative of the left side? Natural log, right? So what is it? Natural log of, that's the value of 3 minus y. And then we have sine of x plus c. There's something wrong with that. It's very subtle. That is very wrong. What now? No, I think like if you plug something in for y, you think of that for a negative number. Okay, yeah, tell me about the chain rule. It needs to be a negative because of the minus y. That needs to be a negative. Chain rule, right? Chain rule gets you all the time. The derivative, if I don't have that, the derivative of this is 1 over, I'm going to erase this, 1 over 3 minus y times a negative 1 because of the inside. That dang chain rule gets you all the time. So the reason I picked this one, among other reasons, is because of that little, not trick, but just something you have to remember that has to be negative if it's 3 minus y. Now if it was y minus 3, natural log of absolute value of y minus 3, the derivative of that would be 1 over y minus 3 times 1, not negative 1. So we would need an extra negative. Very good. Questions on that? I don't want it to give you. I don't want it to trick you on a quiz or get you on a test. I don't find joy in grading tests going, I got him again. I don't do that. I'm like, they forgot again. Anyway, hopefully you won't. As soon as we take the integral, we want to plug the value in. Negative natural log 3 minus 1, sine of 0 plus c. X is 0, y is 1. We have negative natural log of 2 is equal to sine of 0 is 0. So c is negative natural log of 2. We have, I got to plug that back in up here. So negative natural log of 3 minus y is equal to sine of x minus natural log of 2. I can divide by a negative. So natural log of 2 minus sine of x. Now I have to go from a log equation to an exponential equation. So that's all. Log is always equal to the exponent. It's e to all of that junk. So 3 minus y is equal to e to the natural log of 2 minus the sine of x. And then we have negative y is equal to e to the natural log of 2 minus sine of x minus 3. And I divide by negative 1, so that's 3 minus e natural log of 2 minus sine of x. But isn't x squared times x to the third x to the 2 plus 3, right? That's x to the fifth, something like that. And then if we had e to the fourth over e to the second, let's say, that'd be e to the 4 minus 2, that'd be e squared. So you add and you divide. So isn't this y equals 3 minus, that was weird, wasn't it? You see that? Okay, let's try that again. All right, let's try that again, I'm not touching anything. 3 minus e to the natural log of 2 over e to the sine of x. With me on this? Any questions? What we're doing? Matt, you good? All right. That's 3 minus, what's e to the natural log of 2? 2. 2 over e sine of x. Now, if you look at the rubric, or if they came out with a rubric for this, or what AP would say, I wouldn't be surprised if it said this. There. I'll bet that's what they're answering. Questions on that? There's a couple reasons I picked that one. Go ahead. Okay.
Change it on the right side, that's only 2 sine x to e to the natural log, and on the other side it's just
with no absolute value. Is that what you're getting at? Or no? Okay. So let's cover one thing at a time here. Let me help you with this. And I bet other people might be wondering this. If you have log base 2 of 8 is equal to 3. Let's take this step first. We're going from a log function. I want to write this as an exponential. I go 2 to the third. 2 to the third is equal to 8. That's a true statement, right? So its base to this is equal to this. So now I have the base is e. E to all of this is equal to 3 minus y. Make sense? Okay. Second question? All right, so yeah, that's the pattern, you guys. So e to all of this is equal to 3 minus y, just like 2 to the third is equal to 8. Very good. Any other questions? That's it. How you do